Everyone, welcome back to my channel. If you are learning Docker, I hope you find this video informative. Today in this video, we are going to explore a sample app which will allow us to gain hands-on experience with the Docker commands. Let me pull up the browser. So this example voting app is one good example which we can take or make use of to gain hands-on experience. So this is the architecture of the app. We have multiple containers or services which together comprises the or makes the application. So you can call it as a stack. So we have two front end, two back end, and a worker thread, which acts as an intermediate between the two backend databases. Okay, let's switch to our lab environment. So I'm using Ubuntu version 2004. So this is the version of Ubuntu I'm using. I already have the Docker installed, which I'm not covering in this video. Okay, I am in the directory which is test. Right now, the test directory is empty. So what we are first going to do is we are going to pull the source code of voting app from GitHub. There you go. Now let's change our directory. Okay. So we have Docker Compose YAML file. I will encourage to take a moment and go through this Docker Compose file to gain some insight, right? So let's run this command, Docker Compose up, enter. So that will start building our application stack. So which means all the services, all the components that we saw in the architecture diagram will be automatically created for us. And the question is, what did we learn? What commands did we use? We simply ran one command, which is Docker Compose up, right? So this is just the beginning, guys. I'm not going to use Docker Compose up, the second part. So this is just to show you what is the end result of this voting app first, and then we will move to our practicals. Okay, while this is deploying, let me open another terminal. Let me do side by side better so that you can see what is going on in the background. So sudo, this is one command. So as you can see here, we have four applications. The one is Redis, one is Postgre, example voting app, worker, and the voting app and the results. So all the components, one, two, three, four, five components, one, two, three, four, and five components are deployed systematically, and we should be able to now access the app. So let me first check. Now we already have learned one command, that is docker ps-a, which will list all the containers that are running and stopped as well. But since our all four containers are running, so it is only listing the running containers. Now the next command I'll use docker inspect, and we will key in the IP address of the front end that is voting up, which is 6E. That's the container ID. Hit enter. I'm inspecting what is the IP address of the voting app. So let's copy the IP address and go to our browser, hit enter. There you go. So this is the outcome of the first interface, which is voting app or voter. So we can click on the votes, either cats or dogs. Okay, sorry about that. Now let's take a look at the results, so which is 9E. Command is I want to inspect 9E, that is my container ID, and that is running on 72. Let's copy it, go back in here, open another browser. Hi. So 3 votes. Okay, now if I do cats again, as you can see here, it should be, if I refresh, 3 votes. Votes again. Hey, looks like something is not right. So it's not updating. But hey, that's what this app is supposed to do. So in the voter app, we give our vote, that is cats or dogs. And in the results app, we'll get the votes, right? Okay, so this is how we have deployed using the Docker Compose. Now, I don't want to just simply run Docker Compose, which will technically give us nothing but just one command that we learn. So let's first destroy what we have built. Okay, if I do Control X here, just stopping the container now. Okay, so I'm going to run the command docker compose down. Hit enter. So as you can see here, it is technically removing the containers. Now, if I do docker ps-a, everything is gone. Now, these are the images that were downloaded as a part of this deployment. So I'll get rid of these images as well. So basically, this command docker rmi remove image followed by the initial 2 characters of each of the image, like 84, E4, like that. So if I hit enter now, it has cleared all the images. Now, if I do docker images, so that command basically lists all the images that were pulled from private or public repositories. So as of now, we have none. At the same time, we can do PS. So since we have no images, so definitely there won't be any containers running. So there is a direct correlation. Any container that is linked to an image, the image cannot be deleted unless the container is deleted first. Okay, right. So that's the first command, which is Docker Compose, which we have learned. So which will do all the heavy lifting for us. So we don't have to do anything much. We just run Docker Compose, and then the compose Docker will take care of creating all the pulling all the images and creating all the containers for us, right? So, but we want to learn how to build each and every app and link them together so that we get the same results. Okay, so let's begin. First of all, we will pull the images to our Docker host. So in order to do that, we'll go in a sequence. So let's say since our Redis and Postgre are needed, so let me pull them first. the command to pull images, docker pull Redis. If I hit enter, it will by default pull the latest Redis image from the Docker Hub. Okay, now if I do Docker images, you can see Redis is there. Now let me pull, I'm going to use the same version that is 15 Alpine. Awesome. So let's run the command again, Docker images. So we now have the backend databases images pulled, which is Redis and Postgre. Okay. Now let's do the rest. That is, we have a voter app, worker app, and results app images to down fetch or down. Cool. Let me clear the screen first. And now I do ls this directory. So we have a couple of folders here, which is worker, voter, and results. Let's go in a sequence. So I'll switch to voter directory and do ls. So we have a Docker file. Now the Docker file, if you have gone through the learnings of Docker, then this helps to build the image. It has all the instructions, all the commands. Okay, so we're going to make use of the Docker file, Docker build dot -t. I'm going to give it a tag as voting app. Enter. So now we have pulled an image. We have learned to pull an image, right? That's another command that we've learned. Now we will do the same for worker and results as well. So let me switch the directory to results first and then run the same command. So before I run the command, let's check. Okay, we do have a Docker file in there. So Docker build -t. This is our results. So results app. Okay. Now we have the last image to pull, that is worker ls. That is a Docker file. So the command is docker build -t worker app. All right, let me clear the screen first. Okay, now let's rerun the command docker images, which basically will list all the images that we have pulled until now. So there you go. We have worker, results, voting, and the two databases, Postgre and Redis. So we have our inventory ready. Now we can start deploying our container. So let's go back to our flowchart architecture diagram here. So first, from this diagram to look at, if we look at what I can think of is we need to create the two database first because all the other three depends on the databases. Okay, so let's create Redis first. Now create a command. The container creation command is docker run -d, which is basically detach mode. That is, the terminal will not be used by the container. So hyphen name equals to. So we are going to give the container a name. Now this is our Redis database. So we will just keep it Redis and we will tell which image to use. So we'll tell Redis. So as you can see here, the syntax here is docker run means create the container in detach mode. That is, do not run it, use the terminal. Give the name of the container the image that we are going to use, right? Now hit enter. It has created the container for us. Let me not make any change here. Let's switch to the other terminal. And if I show you the previous command, if you remember, docker-psa, so there you go. That's the name of the container we just have created. Okay, let me switch back to the other. Now, there is one more important command that we can use, which is docker logs, followed by the container name or the ID. Now, in our case, the ID of Redis container is 1F, as you can see here, the initial path. So let's review a log how the deployment of this container went through. Hit enter. So there you can see there is a bit of warning, so which is not a showstopper. But if you see here, it says the server is initialized and it is ready to accept connection, TCP. So that means our Redis database, which we have deployed via the container, is healthy. Okay. So we've completed the first part, that's Redis. Now let's create the voter app. Okay. So Docker run -d. We will name it voting line. Let's go back to the architecture diagram again. Now here we are creating this voter app, but it has a connection or link with the Redis database, right? So somehow in the command, while creating the voter container, we have to tell it that, okay, while creating it, form a link, form an integration with the Redis. Okay. How to do this is the link parameter. So we are telling that link the Redis to Redis database. Okay. Hyphen P, which is for port. So I'm going to tell expose this application on port 8000 of the Docker host so that I can access it outside of the host. Okay, and then loading app. So let's revise. Docker run is the command to create a container. Hyphen D is in the attach mode, name of the container that we want. Link is to tell Docker while creating this container with which other container it should be linked to. And the port is exposing of the Docker host so that it can be accessed outside. Okay, and followed by the image. Hit enter. Okay, that's created. Now we will do the same thing, Docker log v7. Right. So as you can see here, it has started. It is good. Okay. So our voter app is created. Redis is created. Postgre we are yet to create, right? So now let's create the Postgre before we even think of creating results or worker. Okay. Docker run happening. We'll name the Postgre as DB and use Postgre image. Enter. Okay, it's created successfully. Let me clear the screen and we run the logs. Uh-oh, my bad. Docker ps -a. Okay, something doesn't look good with the DB container. So the status says it exceeded, meaning it's not running. So let's evaluate. Docker ps ID. Enter. So it says error database is uninitialized and super user password is not specified. Okay. So we have to specify a password, or we can use this environmental flag to bypass it. Okay. So now what to do, right? So what we can do is we can destroy the container, which is not running, that is docker rm remove 55 followed by the ID. That's done. Now, if I do docker ps-a, you can see I only have two apps, which is the Redis and the voting app running at the moment. Okay, let me clear the screen. Now we're on the same command, docker -d hyphen name equals to dd. We are going to use the environmental variable, which is available in the documentation. You can check it out. -e. Okay, right. So let's recap on the command here. Docker run -d name. We already know what it does. So something new we have added, that is -e. So -e is for environmental variable. What we are adding is two environmental variable for the Postgre database, which is available in the documentation. I'll visit that document shortly. So the environmental variable one is Postgres user, and we are giving it the name Postgres. And again, another variable that is Postgres password, and we are giving the same, that is Postgres, followed by the image. Okay, let's hit enter. That's created. Now let's take a look at the logs again. Docker logs ff. So as you can see here, our database, Postgre database is now healthy. Perfect. So we have both voter, Redis, and the DB. Now we have to create a worker container. Let's clear the screen. Worker run -d equal to worker, and we want to link it to DB, right? So if I refer to the diagram again, the worker should be able to talk to the Postgre as well as Redis. So you're telling it that link it to the DB, sorry, and link it to Redis as well. So again, Docker run the name of the container, link it with the two other containers that it should as per the architecture. Right? Now hit enter. Okay, let's take a look at Docker log 72. And we can confirm that it is successfully connected to this Postgre database, as well as it has found the Redis and it's connected to Redis as well. Okay. So that means now when we click on a vote in the voter app, since voter and Redis has a successful connection established, so the votes will be recorded in Redis. Now Redis will update the worker thread about the vote, and the worker thread will record that in the Postgre database. So up to here, we are done. Now the last piece is remaining, which is our result app. Okay, so let's go back and create the results app. Docker run happen b happen name equals to results. Again, we are going to expose it to uh, that was okay, and we have to link it to DB, right? Let's go back here. So our results is only talking to the DB. So we are going to create a link with the DB and results. So Docker run the name of the container. So here we are now very much familiar because we have run a couple of times, followed by the P, that is the port that we are going to expose it to, and the link with other container, followed by the image. Hit enter. Perfect. It's created. Now, again, we will run the logs. 1 4, enter. Awesome. So it has successfully established a connection with our SQL DB. So that means now our all pieces are talking to each other as expected, meaning voter is talking to Redis, Redis is talking to worker, worker is talking to DB, and DB is talking to results, or the other way around. Results is talking to DB to fetch the records of the voter. Right. So now let's do our final command, docker-ps. So we have our 4 apps running. Mm, It gives us the IDs. Okay. So now let's take a look at our app. First of all, 8,000. That's not right. Let's retry. Has our host IP changed? Copy address. 101. Okay. 8,000. There you go. So that's our first photo app, right? Now let's take a quick look here. So let me clear the screen and run Docker logs loading line. So as you can see here, this has not captured anything, right? This is the live logs. Let me click on a vote. Okay, so I have clicked on a vote, so you'll see the difference. If I read on the command again, there you go. You can see the lines. So it has received a vote, which is A, that is cats. Okay, now let's open the results app, which is HTTP 8001.IP is 101. So since I have made one vote, as you can see here, cats is 100% and there is one vote. Okay. At the same time, if I do a check on my Docker logs, results maybe, it says connected. Okay. Now results dot Redis, let's say. Okay, it says connected. DB. Worker. Sure. So the worker thread is the main negotiator in here, right? So if we go back and we see, so it says found Redis, connected to Redis, and processing a vote A. So this is processing a vote and giving it to DB. Meantime, as you can see here, it shows one vote. So this is not a comprehensive app. It's just for testing, so it will not update even if I switch to dogs now. So if I go in here, it still says one vote, and dog is now 100%, right? So if we copy this to another browser, say now dog, a cat's, now we will see the votes as 50-50, and we have casted 2 votes, right? And at the same time, if we open a third browser and again go for our ducks, then it will become 3 votes, okay? So that's the end of it. So this is how, instead of using the Docker Compose, I have used the Docker commands to build each and every service and then link them together so that we gain hands-on experience. And yes, we did indeed, right? So we got to learn a couple of commands, Docker PSFNA, Docker run, what it does, Docker build, Docker pull, all these commands. I hope you find this video informative and happy learning Docker.